All right, guys. So last time we looked at how to create a three-dimensional object in OnShape and kind of compared it to how, what we've learned in Inventor. What we're going to do now is to see how to take our three-dimensional object in OnShape and create a two-dimensional drawing from it so we don't have to recreate all of that work. So in order to do that, you'll be in your part here, and you'll see at the left we have this kind of feature browser, and you can kind of hide it and open it by clicking on this little tab here. Now, in it, there's a bunch of stuff going on. There's stuff related to the geometry of your parts and the sketches and extrusions that create those parts. And then down here is a list of all the parts in your 3D model. Now, our model is very simple. There is only one part in it, and it's called part one. You can choose to rename it if you want by right-clicking on it and changing things. For now, we're not going to worry too much about that, but there's a lot of stuff in here that we can go ahead and look at. You can rename it, you can change properties, you can change materials, and all sorts of things like that. For now, what we're going to do is we're going to go ahead and just create a drawing of part one. So we're going to go ahead and click on that, and it's going to ask us a bunch of stuff. So if we go ahead and look at this, so right now I have just one showing up. If I click on this, so it's basically going to show you all of these different potential templates that you can use. There are a bunch of different things, and you'll see ANSI, you'll see ISO, you'll see A, B, all this crazy stuff. So, what are these things? So, ANSI and ISO are both national standards organizations or international standards organizations in the case of ISO that create standards for all sorts of different things. If you remember ISO from our sort of safety organizations unit, they create standards for business practices, they create standards for safety things. They also create standards for how engineering drawings get drawn up and how they get documented. And ANSI is very, very similar. For our purposes, they're essentially equivalent. You'll note that if you look at the bottom left here, there is a slight difference. So the four views you'll see you've got a front, a side, a top, and an isometric. And if I click on the ISO views, they're a little bit different. It's like a top and then a front and then an ISO and then a side. And so it's just a difference. The main difference between these different formats is the orientation of these views. We are going to always be using ANSI style because that is kind of the way things are typically done in the US, but ISO style is a bit different. Um, so we'll be using ANSI style. Obviously the inches and millimeters, those are probably the units, right, that we're going to be using in our drawing. So we will be using millimeters because that is more of our metric unit than inches. And then we have these letters, A, B, C, and D. Those refer to different paper sizes. And so we're going to be using A. So we're going to look at ANSI A millimeter is going to be our drawing template. That'll just be always the one we use. Now at the bottom left here, you can choose to either start with no views, in which case you are going to manually place which views of your object you want, or you can choose to start with all four views already populated, your front view, top view, side view, and isometric view. Now that saves us a lot of work, so we're just going to go ahead and select that and hit OK. So it's going to take a moment and automatically generate your file for you. And once it's done, you'll see we have basically our little sheet of paper. We have our four views already set for us, so we didn't even need to go in and place them, which is nice. And then we have kind of this kind of info block down at the bottom right. And there's some stuff already populated. It'll have your name in there. It'll have the date that this was created automatically put in. There's a few things, other things, the scale of this image, and we can change the title. So for instance, if we wanted to rename it, we could just double click in here, and then we can highlight and just say, I'm going to call this origami heart. And it would help if I could spell. And then you just hit check, and boom, now there's some text in there. So we're almost done now, right? We have our paper, we have our views. What's missing? Well, we need dimensions, right? We need to give people who are looking at this enough information to be able to reproduce our object. So we're going to go ahead and do that. Our dimensioning tool is up here. So we're going to click on dimension tool. And it's just like our dimensions that we set in our two-dimensional sketches. You can dimension either a whole edge, or we can dimension between points. So I'm going to dimension between this point and this point. And I can drag it to the left, or I can drag it down. I'll go ahead and drag it down. You can see 30. Well, I thought I set it to be 3. Well, in our drawing, we're using centimeters as our units. We set 3 centimeters. In our, in our sketch, we're using centimeters. In our drawing files, the standard is using millimeters. So 30 millimeters is 3 centimeters. Easy peasy. So that's all of our numbers in here are going to be multiplied by 10. So now I'm going to go ahead and give myself the vertical dimension here. And you're basically just going to go through and continue giving yourself all the dimensions that you think you would need in order to let someone actually reproduce your work here and reproduce this object. And you can carry on like that. Now you can also choose to dimension an entire edge like this and give yourself the actual total length of that. And obviously, if you wanted to find this edge and you knew these two sides, there's a couple different ways you could do that based on trigonometry or Pythagorean theorem or what. And you'll just carry on and continue dimensioning as normal. Now, of course, you don't forget, if you're making an object like this, you're also going to need to know the depth of this object. That's something we cannot get from the front. So you're going to go ahead and carry on, continuing on to do that until you've filled out everything. And once you have done that, then it's time to actually save your part. So the last thing you're going to need to do is actually save your work. We can go ahead and export this whole thing as a PDF. To do that, it's relatively easy. All you need to do is come down to this bottom left here. There's a couple different tabs. Now, obviously, if you click on these tabs, it'll take you to different parts of your file. You can look at a whole assembly of things, which we're going to get to later. You can look at the drawing file that you've just created. You can look at the 3D object that you have that your drawing is based off of. So we're going to look at the drawing file. If you right click at the drawing tab, you can choose to do a bunch of different things. We're going to go ahead and export it. So go ahead and choose export. You can give it a name. We'll say origami heart drawing. You can choose a bunch of different formats. I'm going to leave it as a PDF, but if you wanted to export it as something that Inventor could read, you could use some of these other options. We're going to leave all of this other stuff the same, normal text, color, and we're going to just download it. You could also store it or open it in a new tab or whatever, but we're going to download it. So hit export. It's going to take a moment, turn this into a PDF, and give you the option to download it. So once that's done, a little dialog will pop up, and it'll give you an option to save it. And so you can go ahead and say, okay, we're on a heart drawing, and I'm going to click on save, and then boom, download's complete. And if you go ahead and open it up, open up a little PDF of our little drawing file. Ta-da! Here we go. And so that's how you create a simple two-dimensional drawing out of a three-dimensional part in OnShape. So I hope that was useful, and I hope that helps as you go forward and figure out how this works compared to Inventor. So take a look at that, and let me know if you have any questions.